Assalamualaikum, I'm Hairul Nizam bin Madarus. Today I want to explain how to determine the difference of BMI between athlete and non-athletes. Assume the sample was randomly selected and alpha equal to 0.05. This is a independent variable IV2 group, athletes and non-athletes. Dependent variable dV numerical difference of BMI. Observation sample is independent athlete for 30, non-athlete 30, because central limit theorem normal is more than 30. Distribution normal and parametric that use the independent t-test. So for the first step, one is the generate hypothesis H null. The mean BMI between athlete and non-athlete are same. For the H alternative, the mean between athlete and non-athlete are different and it's two-tailed. The level of significance is alpha equal to 0.05. The assumption dependent variable is numerical data of BMI. It is assumed the sample was randomly selected. Two samples are independent of each other. Athletes and non-athletes are independent observation. So look at the SPSS. So to check for normality, use and open the IBM SPSS, and this is IBM statistic for athlete and non-athlete, athletes and non-athletes. So go to the analyze and descriptive statistic and go to explore. So the BMI insert to the dependent list and status to the factor list. Go to the plot and then change the explore plot to histogram and normality plot with test. Then click continue and click OK. So the output you can see from the normality. This is a test of normality. From statistic technique, p-value Shapiro width for athlete equal 0.92, more than 0.05, not significant and it's normal. P-value Shapiro width for non-athlete equal to 0.601, also more than 0.05 and not significant and it's normal. From the graphically both the show normal distribution. So look at that. I show the graph. So this the curve of the histogram, and one more graph. So you can see the graph. The assumption is made, distribution is normal. Then test statistic, conduct an independent sample t-test. Go to the analyze and compare mean and go to the independent sample t-test. The box of independent sample t-test put the BMI insert to the test variable, and status the grouping of variable. So define the group. For the group 1 is number 1 and group 2 is number 2. Click continue and click OK. So the descriptive statistic show mean and standard deviation of both of group. The two population have the same variance. For check for equal variance using the leaven test. If the leaven test is not significant, read the t-test result of the upper row. Then this is interpretation report of result APA 7 style, and the conclusion non-athletes mean equal to 26.57, that the standard deviation equal 1.06, reported had significantly higher total BMI than athletes, mean equal to 23.03 and standard deviation equal 1.03. The T58 equal to negative 13.20, P less than 0.05. For the second question is to determine the effective of intervention by measuring baseline BMI and BMI 1 year after intervention. Assume the sample was randomly selected and alpha equal to 0.05. The independent variable IV, there is two group, pre and post of BMI. Dependent variable DV, numerical effectiveness of intervention. Observation sample dependent. For the same people, there was 60 sample. This is a normal for the central limit theorem, equal n more than 30. The distribution parametric, and use the PET test. So the hypothesis H null, there is no difference in the effectiveness of intervention of pre-BMI and post-BMI, different equal to 0. For the H alternative, there is difference in the effectiveness of intervention in for pre-BMI and post-BMI, different not equal to 0. The level of significance is alpha equal to 0.05. The assumption different in the effectiveness of intervention. Dependent variable is numerical data. Assume the sample was randomly selected. All observation are paired or dependent pre and post effectiveness of intervention. The observation differences before and after are normally distributed. So we go to the SPSS. So before check the normality, we create the new variable of different type for pre and post column, and go to the transform, compute the variable, and type fill the for the different DIFF for short form, and you can use the type label, fill the difference, and then click continue. For the numeric expression, you choose the BMI pre and click insert, and minus for the BMI post, insert, and then click OK. Then the result is a new variable of the column at the column. To the check for normality, go to analyze and descriptive statistic and explore. So put the different variable into the dependent list and go to plot, change to histogram and tick the normality plot with test and then continue, then click OK. So this output of statistic of test of normality. This is normal, and then the histogram. So we can see the curve is normal. This is a histogram distribution is normal, and then the test statistic, go to analyze and compare means and paired sample t-test. So insert the variable at the variable 1 and the variable 2 for the post BMI, and then click OK. Then the output statistic will be show the paired sample statistic with the mean 34.40 with the standard deviation 1.834 and the paired sample test with the T 22.20 and DF for 59 and P value is 0.000. And for the interpretation, different effectiveness of intervention by measuring baseline. So this is interpretation, and the conclusion, pre-BMI mean equal to 34.40 standard with the standard deviation 1.834, reported had significantly higher level of effectiveness of intervention than post BMI with the mean equal to 29.22 with the standard deviation equal for 1.748 with the T 59 and equal to 22.200 with the P less than 0.000. For the third question is to determine the difference of weight between groups. Assume the sample was randomly selected and alpha equal to 0.05. For the independent variable IV, they have three groups, group A, group B and group C. Dependent variable DV is numerical for the difference of weight. Observation sample is independent. The total of sample is 39. This is a normal central limit of theorem because the equal n more than 30. The distribution parametric one-way ANOVA. For the hypothesis, H null equal to group A equal to group B and equal to group C. H alternative, at least two of the treatment group are different. The level of significance is alpha equal to 0.05. The assumption random sample is different of weight and the observation are independent. For each observation refer to different group. Now we look at the SPSS. check the distribution of is normal. Select the analyze, descriptive statistic, and explore. And input the weight for the factor of weight for the dependent list and group for the factor list, and click plot, change to the histogram and tick the normality plot with test and continue. Click OK. And we get the result of the output, the descriptive, and for the mean 48.69, and the group B mean with the 49.69, and the group C for 54.08. And the test of normality, group A, group B, and group C, with the histogram. The curve is normal. This is a normal curve for the distribution. For the test statistic, using the SPSS, go to the analyze and compare means and one-way ANOVA. So the weight put into the dependent list and group for the factor, and click the post hoc and tick for the Bonferroni, and continue. Go to option and choose the homogeneity of variance test and continue, then click OK. So this the test homogeneity of variances table, ANOVA table, and post hoc test. The p-value is equal to 0.000, reject has null, and at least two of the group are different. And check the which group are significant different using post hoc test. On Bonferroni, the p-value for group A versus group B is 1.000. This is not significant. The p-value for group A versus group C is 0.001, is significant, and the p-value for group B versus group C equal to 0.005. It's significant too. For the this is interpretation report of result. Use the APA7 style, and conclusion and analysis of variance show that the weight was significant. The F 2 and 36 equal to 9.83, with the p-value equal to 0.000. Post hoc analysis using the Bonferroni indicated that the weight was significant between group B mean equal to 49.69 and standard deviation equal to 3.903, and group C mean with equal 54.08, with the standard deviation equal to 3.546, with the p-value equal to 0.000. So thank you, that's all for now.